The topic for today is micro operation, fetch cycle. Micro operation in fetch cycle. The execution of a program consists of sequential execution of instructions. Each instruction is executed during an instruction cycle made up of sub-cycles, that is fetch, indirect, execute and interrupt cycles. The execution of each sub-cycle involves one or more shorter operations, that is micro operation. Micro operations are functional or atomic operations of a processor. In this video, we'll examine micro operations to gain an understanding of how the events of any instruction cycle can be described as a sequence of such micro operations. Let us start. Welcome to our channel Engineering and Technology for You. If you are not subscribed to our channel, kindly subscribe and press the bell icon so that you get notifications for our future videos. The topic for today is micro operations fetch cycle. Let us start with the introduction. See, as you all know, the basic function performed by a computer is execution of a program. Now, execution of a program, here program means nothing but a set of instructions stored in memory. So the processor does the actual work by executing instructions specified in the program. So if you take a program, it will have instructions, or we call it as a set of instructions, and it is the job of the processor to execute instructions. Now, in its simplest form, instruction processing has two steps. The processor first reads or fetches instruction from the memory. Now, this reading of instruction is done one at a time and then executes each instruction. Then program execution consists of repeating the process of instruction fetch and instruction execute. So these two processes, instruction fetch and instruction execution, they are continuously repeated. So that will constitute the program execution. Now, the processing required for a single instruction is called an instruction cycle. We have already discussed the instruction cycle when we studied the computer function. So there is a separate video for that. Those who are watching this video without the introduction part, you can go and watch that video on my channel. Then let us come to the elements of program execution. See, the operation of a computer in executing a program consists of a sequence of instruction cycles with one machine instruction per cycle. So here, when we are studying this execution of instructions, we must know what is the instruction cycle, and then only we will be able to understand how the program execution will take place. Each instruction cycle is made up of number of smaller units. Now, the instruction cycle is a general term, and particular units for instruction cycle, they are nothing but the fetch, indirect, execute and interrupt. These are the different instruction cycles with only fetch and execute cycles always occurring. As we have seen, the execution of program consists of execution of the instruction, and this is done by fetching the instruction and then executing the instruction. So these two are common for all the instructions, fetch and execute cycle, whereas the indirect and interrupt, these two cycles, they will be present if they are required by the instruction. It will depend on the addressing mode and the type of instruction. If there is an interrupt, then it will go for the interrupt cycle, or if the instruction has to fetch data, then it will go for the indirect cycle. So in this way, we see that each of the smaller cycles involves a series of steps, now each of which involves the processor registers. So when we are executing the instructions, at that time we take the help of the registers, processor registers, maybe the general purpose registers or other registers in the processor. So the instructions are executed in steps. So we refer these steps as micro operations. So here the micro refers to the fact that each step is very simple and accomplishes a very little. That means only some work is done in that. That's why it is called as the micro operation. So here, whatever we have studied the concepts, say program execution, then instruction cycle and micro operation. Now these are shown in the figure. Let us see the figure. So program execution, that is the main task of the computer. So it is done with the help of different instruction cycles. So each instruction will have its own instruction cycle. Now this instruction cycle, again it consists of the fetch, indirect, execute and interrupt cycle. And fetch, indirect, execute and interrupt cycles. And this, again, each of these cycles, fetch cycle, it is divided into micro operation. So this is another micro operation, this is another micro. Similarly, indirect cycle will be divided into micro operation. Same thing with the execute and interrupt cycle. So here in this video, we are going to study the micro operations related to the fetch cycle. Let us go further. So program execution and micro operation. Let us summarize whatever we have discussed so far. The execution of program consists of sequential execution of instruction. Remember this. When we are executing a program, the execution of instruction will take place sequentially, except in case of branch instruction, the execution will be in a sequence. In case of branch instruction, we'll have to take a jump or go back, take a loop, like that. So now here each instruction is executed during an instruction cycle made up of shorter sub-cycles, that is fetch, indirect, execute or interrupt. So these are the different sub-cycles of an instruction cycle. Now the execution of each sub-cycle involves one or more shorter operations, that is the micro. That is what we have just now discussed. So micro operations, they are functional or atomic operation of a process. So micro operations are carried out in the register, and they are the functional operations of the process. Now in this video, we'll examine micro operations to gain an understanding of how the events of any instruction cycle can be described as a sequence of such micro. So basically we are going to see the phase cycle in details in this video. Let us go to the flow of data during phase cycle. Now here, if we look at the phase cycle, it will occur at the beginning of each instruction cycle, because for executing any instruction, first we have to fetch it. So fetch cycle is the first cycle in any instruction cycle, and it will cause the instruction to be fetched from memory. So fetching from memory means getting the instruction from memory and loading it into the process. That is fetching of the instruction. So we assume that this is the organization structure, processor organization. So here you can see the CPU or the processor. It has the memory address system, MAR. Now this is connected to the address bus. The address bus, it will have the address in memory read or write operation. So it will carry the address. Then we have the memory buffer register. Now this memory buffer register or MBR is connected to the data bus. You can see this is the connection. It is connected to the data bus, and it contains the value to be stored in memory or the last value read from the memory. So it will have the data. Then we have the program counter. Now it will hold the address of the next instruction to be fetched, right? And this IR is nothing but holds the last instruction fetched, and the control unit is controlling here, will control everything. And this is the memory, and we have the control bus for controlling different things. So this is the common structure or organization of a processor. This we have seen in the last video, processor organization. Then this organization, if you understand, then only it will be possible to understand the micro operation. Let us go further. Now the sequence of events in the fetch cycle. So let us look at the sequence of events for the fetch cycle. Say how the processor registers are loaded and how they will be what will be the sequence of operations. So here if you look at this first figure, A figure, beginning before T1. So whatever instruction we want to say process or execute, the address of that instruction will be in the program count. Now in this case we have taken the address as 0000 0000, then 0110 0100. That is the address, hexadecimal. So PC will have the address of the instruction to be executed. So this address, so the first step, in the first step will move the address to the memory addresses. So this will be copied to the memory address. That will be the first step. So this memory address register, it is the register which is connected to the address bus. So this address will be copied to the memory address. So that will be the first step. Then the second step, here in the second step, is to bring the instruction, that is the first instruction to be executed on the address bus. Now here we'll give the read command, and whatever data is available on the data bus, so that will be loaded into the MBR. Then here, third step, it will be to move the contents of the MBR to a instruction register. So this MBR contents, now in this case it is 001 000 100000. So this hexadecimal value, it is copied to the instruction. So these are the micro operations which are done in the fetch side. Now let us go further. So the sequence of events what we have discussed, it is given here. So first will be the PC will have the address of the next instruction to be executed. So this address here we are assuming it is 1100 So this address or whatever the contents of PC, first step is to move the address to the memory address register, MAR, because that is the only register which is connected to the address line of the system. We have seen the figure for that processor organization. Then second step is to bring the instruction. So whatever desired address in MAR is placed on the address bus, and the control unit issues a read command on the control bus, and result appears on the data bus and is copied into the memory buffer register, MBR. So the address is here MAR, memory address register, whereas the instruction, it will be in the MBR, memory buffer register. Then once this is done, we'll have to increment the PC by the instruction length to get ready with the next instruction, because these two actions, read word from memory and increment PC, do not interfere with each other. We can do simultaneously. So this will be done simultaneously. And then the third step is to move the contents of MBR, that is the memory buffer register, to the instruction register. So this frees up the MBR for use during the possible indirect cycle. Possible indirect cycle means if we want to load another, say, address or data, in that case that has to be that will be coming from the MBR, that is the memory buffer register. Because as we have studied the different addressing modes, in case of immediate addressing mode, after the opcode, operation code or instruction, will have the data, so that has to be loaded. So that will be done during the indirect cycle. So that will not be part of the fetch cycle. So these are the three steps for the fetch cycle. So what is the first step? It is to move the address to the memory address register. Then second step is to move the instruction opcode to the memory buffer register, and the third step is to move the contents of memory buffer register to the instruction register. Only here we have to consider the increment of the program counter for the next instruction. Then let us have the discussion on this. So simple fetch cycle consists of 3 steps, but there are 4 micro operations. Each micro operation involves the movement of data into or out of a register. So here we have seen the registers: program counter, memory address register, memory buffer register, and the IR, that is instruction register. So when we are defining it, so during T1, program counter contains, that is the address of the next instruction to be executed. It is loaded into the memory addresses. Then whatever address is there, from that memory we are taking the contents of that memory, that is nothing but the instruction. So that will be loaded into the memory buffer register. That will be coming on the data bus. So address bus will have the address of the instruction, and the data will come on the data bus. Then after this, the PC will be incremented by 1 for the next instruction. And the third step during T3 will load the memory buffer register contents, that is the opcode of the instruction, into the instruction register. So depending on the length of the instruction, the PC will be incremented by 1 or 2 or 3, depending on this length of the instruction as per the instruction. So these are the sequence of events that are carried out. Now here we see that during T2, the contents of memory, they are loaded into the memory buffer register, that is the instructions opcode of the instruction is loaded into the memory buffer, and the PC is incremented by 1 or 2 depending on the instruction. So these two are done simultaneously. Then further if we go, if we assume the clock is available for timing purpose, now generally the processor will have the clock for the timing purpose, and it will be it will have the clock pulses which will be defined by the particular clock frequency of the processor, and the clock frequency will define the time unit. So a clock pulse, it will depend on the clock frequency. 1 by f will give us. Thus all the time units are of equal duration, and each micro operation can be performed within the time of a single time unit. That is very important. So we have the first time unit T1. So the contents of PC are moved to the MAR. Then second time unit will move the contents of memory location specified by MAR to the memory buffer register and increment by I the contents of PC. So here I is the length of the instruction. So the PC will be incremented by maybe 2, 1 depending on the instruction. And in during the third time unit, that is T3, move the contents of MBR to IR, memory buffer register, to the instruction. So these are the operations carried out. Here we must note that the second and third macro operations both take place during the second time unit. So here you can see these two operations, they are taking place during the second time unit. And the third macro operation we can say grouped with the fourth without affecting the fetch operation. So here we can increment the PC and at the same time we can load the contents of memory buffer register into the instruction register. So that we can change. So the grouping has now changed. Instead of T2 performing this operation, it is given to T3. So this is possible. So there are simple rules for grouping of micro instructions. Rule here is the proper sequence of events must be followed. The most precise because the memory read operation takes use of the address in MAR. So MAR, memory addresses, it will always have the address of the memory reading. Then conflict should be avoided. One should not attempt to read or write from the same register in one time unit because the results would be unpredictable. For example, the micro operations, the memory to the contents of memory, they are copied to the memory buffer register, and this memory buffer register to IR do not occur during the same time unit. That will results into so this is what you will have to follow the rules for the groupings of micro. So with this we come to the end of this video. If you have any queries, you can contact me on Facebook, Twitter, Gmail or Instagram. Then if you like the video, press the like button, share with your friends and subscribe to our channel Engineering and Technology for You. And don't forget to press the bell icon so that you get notifications for our future video. Now here directly you will get the notification about the future video. I will be covering this unit in the future videos. So don't forget to press the bell icon after subscribing to our channel. Then thanks for watching. Have a nice day.